Knowledge is the key currency of innovation. Not just scientific knowledge in all its guises, but knowledge and its use from a whole range of different professions. Knowledge is generally accepted to be and to mean justified true belief, in the sense that the holder of the knowledge should believe that the evidence relating to the fact is true, and be justified because the source, the quality, and the totality of evidence available is sufficient to warrant such a belief. It is important to note that scientific evidence is progressive, time sensitive, and that belief is based on subjective feelings, thoughts, values, and ideals that influence interpretation of evidence. There is rarely an absolute. Science is progressive in the sense that scientific research generates new knowledge. However, while research that contributes to innovation may or may not advance science, it should challenge belief in established knowledge and thereby ideally enable innovation. Progress and advancement in science can be considered in terms of additional knowledge generated, the quality of knowledge generated, and the value of the outputs that it generates. There is a commonly held belief that research excellence is required for progress in science, whereas it may actually be desirable, but it's not a necessity. Scientific excellence is a quality of research as an activity, but it is not an essential requirement for scientific progress nor for innovation, and the way in which it is measured will determine that relevance in terms of excellence and innovation. Accumulating citations in scientific scholarly journals may be a comfort for researchers and useful in their career progression, but is certainly not the best measure for evaluating excellence nor progress in innovation. Progress in science has been addressed by those interested in the social and philosophical aspects of the subject. Most notable in this regard, and the man I have the greatest respect for, is Thomas Kuhn in the 1960s, who described progress in science through revolutions occurring through what he referred to as paradigm shifts. In my book on the nature of scientific innovation, I use the definition of a paradigm that used by Turk and Orman in 2016, where a paradigm is a specific theoretical orientation based on a particular epistemology and research methodology, reflective of a particular scientific community at a particular time in history. It also frames and directs the nature of the type of research inquiries generated from the theoretical orientation, as well as provides the fundamental basis for evaluating the results of the generated research. This latter quality of framing the research inquiry and of providing the fundamental basis for evaluating results encompasses both the limiting and liberating aspects of paradigms, since there will always be things that remain external to any particular frame. Hence, if the relevance of results are constrained by the paradigm frame, then only limited interpretations that work within the frame become available. Thus, belief in the paradigm and the paradigm alone limits interpretation and what is considered true and justified. However, at the boundaries of the frame exist new possibilities for discovery and invention, but it requires those individuals who are prepared to question and challenge the orthodoxy of the paradigm to undertake research in those areas. The famous physicist Max Planck's principle was that scientific change does not occur because individual scientists change their mind, but rather that successive generations of scientists have different views. In what Max Planck says is correct, then what a waste of time, opportunity, and innovation, because scientific research is being restricted by those who conduct it from a limited perspective of paradigms. There is a need to have means by which paradigms are formally acknowledged within scientific research, and mechanisms by which those who, in their defense, hinder, delay, and prevent scientific progress because of their belief in a knowledge that can only ever be transient and can never wholly be the totality of evidence, even at a given time. Scientists can and do limit progress in science by commitment to paradigms and in doing so do themselves a disservice and undermine the development of potential innovative solutions needed by humankind. The means by which explicit mechanisms for defining and declaring paradigms and of minimizing their negative impact within science can be introduced, and the way in which this may be possible is outlined and considered in more detail in my book.